there's actually some lists out there called do not scan lists. And the do not scan, and you shouldn't scan anybody that isn't yourself. But the do not scan lists are the people you really don't scan. So Stratcom, which is responsible for all the nuclear weapons, Special Operations Command, Central Command, Cyber Command, MacDill Air Force Base, NSA headquarters, lots of places in Maryland. There's a huge list of IP addresses that, like, if you send traffic here, you're going to wind up way high on a radar. What's kind of fun about that, but don't ever do this, wink, wink, you could put DNS entries that when somebody sends you a DNS query and they're like, hey, what's ecommerce.yourdomain.com? You're like, I don't know, some box over at the NSA. And if they're doing a script and they're querying every host name that you resolve, and they hit just every single IP address, they're going to start tagging 3-letter agencies. So again, I don't think that anybody should ever do that, but theoretically that's something that could occur just through DNS. When they're trying to map your organization, you give them IP addresses of hostile people. Could be foreign intelligence agencies, right? You're like, here's the FSB listening post in San Francisco, for example. Like, there's a dedicated building for that stuff. With an internet connection, you can find it published. You can say, my hosts are over there. Now, that may get you some attention in reverse, because as we're going to learn with Maltego, we can look at certain domains and IP addresses and see what names point at them too. So it's a two-way street. Fun stuff, though. Any questions on internet addressing or numbering? I guess one other thing to consider is, real quick, is just BGP, and we'll take a break. What is happening with Whois now that they've failed the GDPR requirements? I don't know. Not certain. So with BGP, Border Gateway Protocol, you can run any protocol you want on the internet so long as it's BGP. This is classified as what's called an EGP, or Exterior Gateway Protocol. And that's a good term to understand. Exterior gateway is what happens outside of your gateway, where interior gateway, that's right, it's what happened inside your company. So when you have a router or firewall that connects you out to the internet, this is kind of your point of demarcation. On the left-hand side, we're responsible for all things. We have control over IP addressing. We have control over the way everything works. Once we hook up to service providers, there's not all that much that's under our control. Many times when you get IP addresses for your organization, they could be leased from a service provider. So for example, at my house, I can get static IP addresses. And you can go to your service provider and say, hey, I want these IP addresses. If I get 5 IPs or 10 IPs from my provider, they're never going to change. But if I ever cancel that provider, I lose those IPs if I move somewhere else, because these IP addresses, if you were to look on Aaron or Iana, they're part of a block that belongs to the service provider. The alternative approach is what we call provider independent addressing. It means you own your IP addresses and you bring them to the service provider. In order to do that, that's where you speak BGP. You go, I have an IP address block, like HP's got the 15 block. And they go, we want to announce that to the world. So the interior gateway protocol, this is where we're typically using RFC 1918 addresses, private addresses, right? And what we use to move these around internally are interior gateway protocols. This is where OSPF lives, EIGRP, RIP, ISAS, etc. Those are examples of interior. Once you get onto the internet, everything's BGP. On the internet, everything is public addresses. And when you look at it, it's really just a collection of different networks. So you have carriers, which we'll sometimes call like a tier 1 provider. They've got their own global network, or at least continental network. And then there's smaller providers that reach out to smaller customers. And it really just creates this web. The connections between these different little clouds, each one would be somebody different. Like this might be level 3. This might be global crossing, etc. There's lots of different service providers out there, Verizon, AT&T, etc. As these networks connect together, the connections between them, this is called peering. And the way that calculations are done is you go, I want to get from point A to point B, crossing the fewest providers. So you're not even really considering bandwidth or anything. You go, I just want to get from point A to point B, and you typically use something called AS path sets to get there. Each of these organizations has what's called an autonomous system number. It's just a unique number that identifies it. But as you look at traffic passing around the globe, we can look at IP addresses, which we'll see in traceroute. Those IP addresses tend to live in different autonomous systems. So we can tell a lot about a company. If you've got a company that is big enough to run BGP, so they've got their own provider independent addresses, they're typically going to announce routes through multiple routers to multiple providers. It's what we call dual homing. There, like that. So I can look at AS paths and I can say when I get to this particular IP address that's a destination, what does the AS path set look like? What does my trace route look like? And I can do trace routes from different places around the globe. I can try it from different sources. And it's going to eventually show me all the different paths in and out of that company. It starts to become really exciting. This is how we can start to geographically figure out where things are located. It's not impossible to tunnel from one area to another, but it's typically not done because it adds latency. So again, these are just ways that we can learn a little bit more about the way that a company operates. When we start to look at different IP address blocks, again, this is going to show us what's private versus what's public. Is it something that's hosted on AWS? Is it something that's hosted on DigitalOcean? We're going to know because when I resolve that host name and it comes back to an IP, I say who really owns that IP address. And there's some fancy things that you can do with announcing IPs from different locations. But for the most part, what we see here should be fairly accurate. Realize that the data that we learn from a lot of these tools can be spoofed in some circumstances, but typically not. Cool. So again, takeaway from that, autonomous systems are just networks that connect to other networks. By looking at an AS path, we can see who the providers are to a particular customer. And again, it depends on what kind of access and friends you have, but if you're trying to target their communications, you could find someone that works at this provider or that co-location facility where things are hosted, and that's where you can potentially get access to the cable. All right, so that was who is. Again, here's just a who is lookup. You've got the name servers here. These name servers are going to correspond to IP addresses. Once we have those IPs, we can figure out, hey, do they even run their own name servers or do they use somebody else? Maybe they use somebody else because they're doing load balancing with it. Fair enough. When they load balance, do tons of queries over several days, see the different destinations that they point us to. A lot of time web servers are hosted in the cloud. A lot of times VPN servers are located on premise. So that's why we look for host names like vpn.whateverdomain.com. So here's a handful of different lookup tools. Like I said, you can just go directly to Aaron and run it. You can also do it from the command line of a lot of different operating systems. Any question on GeoIP information? GeoIP just says this IP address is basically part of a bigger block that's located in this location. Different people publish GeoIP data, and this is something our firewalls are starting to consider. So when I build access lists in a firewall, you used to always say source and destination IP address. Now when I'm talking about the source, I can use things like Active Directory users. I can talk about a particular country. I can talk about individual flows from different VPNs. There's lots of different ways to classify traffic. GeoIP lookups and GeoIP data just means that I have location information about IP addresses that I can consider when delivering content. There's a pretty neat company out there called MaxMind. Not only do they allow you to do lookups, but they also allow you to dynamically provide different content to different customers. So let's say that I have a dog grooming business in Oldsmar, Florida, And I don't think anybody from Russia or Pakistan or Syria or Iran is ever going to come get their dog groomed there. So if I see connections coming in from countries that I'm not sure are going to be customers, they may, provide some problems, I can say, if I see these potentially problematic IP addresses coming in, serve them this HTML document, which might just be like a trifold brochure. It's static content that says these are our services, here's our phone number. If it's from local IP addresses, give them website number 2, which is fully featured. You can book things online. You can get all these details.